So the second process which CO2 can leave a tissue is where the CO2 itself binds the hemoglobin. So here's the tissue. It's creating CO2. And here is our red blood cell. With a hemoglobin in it. Well, a whole bunch of hemoglobin. HbO2. Because it's currently carrying oxygen. Now, when the CO2 comes in contact with the hemoglobin, and it's not converted into carbonic acid, it can bind to the hemoglobin protein. And what that does is CO2 is also an allosteric inhibitor, which kicks out the oxygen. But before it can bind to it, it goes through a little chemical change where the CO2 loses a proton. So it becomes CO2 negative. And the proton is just a hydrogen, because hydrogen is one proton, one electron, but this is just a proton without an electron. So it's a positive hydrogen. Now, when the CO2 binds to it, it kicks out the O2 and goes in itself. So CO2 goes right into the hemoglobin. However, the CO2 negative. However, it produces NH+, which is also an allosteric inhibitor of the hemoglobin. So the H+ would go and bind to another part of a hemoglobin, which would kick out more oxygen. So this way, twice the oxygen is kicked out. So since there's H+'s going around here, and here's like another hemoglobin, and then its O2 that was once in there gets kicked out, now there's an H+ in here. And that means there's more oxygen going out into the tissue. So the more CO2 present, the more O2 that gets pushed out into the tissue.